this video we start to move to project 5. We will make our nice pen holder. You can place that, it can be this size, and you can place that on your desk or on your table. So the learning part is first we will have this rotate extrusion, and also we will try to utilize this exploratory design approach to do the design module from inside out. So let's try to do this first, the rotate extrusion. And before running, I just upgrade my OpenSCAD from this stable version, 2021 January version, to this developing version. So on Windows 64-bit only have this September 10th version, but if you're using the 32-bit, you can get even latest version about 1 week early. It's the little nice of on the UI, and also the icon is changed, but let's try to use this to the model to see whether there's any other change. So see here, let's quickly go to our new folder. Now we have the phase number 5. So we use this 05 pen holder with the first model. If you read some the text about the description for rotate extrude, you can have some ideas on the difference, how you can get this and the left. Let's starting to make this basic one. So to make you have an idea is let's do our arc base equal to 5, arc angle equal to 70, arc radius equal to 20. So I can feel the color of font is also changed compared to the earlier version. So that is, we can feel some more things. So first, let's starting from this basic shape. Square is a 2D shape. We have arc base, and we have this one, and we will have a circle. Let's highlight our circle. Circle, the diameter equal to arc base times 3 divided by 5. So this calculation is used here. We have here. So as the diameter of 3/5 of the square. So we try to make that in the inside of this height. So we gave some phase number 18. Then we have this in the middle, and what we need to do is we will translate this first, translate to arc base 0. Because it's a 2D, it's mentioned here, is you only need to translate based on X and Y, no need to translate to Z. And then this radius, is we also need to translate that to the middle of the Y. So just put that into minus Y. 0 minus arc base divided by 2. Then we have this one. So first we have this shape. But remember, we mentioned in last video, even with you see this as a 3D, but when you press F6, you can see this actually just our 2D shape. It's not means they have our thickness. The thickness is just during the preview within the F5. They show you something on the Z area. So that is should be remembered clearly, and don't confuse between 2D and 3D. After that is let's make this joint. Joint is using union, and we have this also putting here and give a tag. It's no change, but actually now they are become one shape. And what we will do is we will shift this to positive, negative, and we can have this rotate, extruding. So first let's do the translate in the arc radius. Let's translate that to the minor and 0. Let's see, it's back to the negative x. And what we can start to do is we can see the effect of this rotate. Extrude. There's two. This perimeter. One is you can define the angle, but as mentioned here in the old version, you cannot define angle because it just rotate, and you can only define the phase number. So if you don't give anything, so they will have the this ring coming. Only in the latest version or the recent version, they allow you to define the angle. So first, let's make this phase number 100, make that smooth, and we can start to give angle equal to arc angle. Then we have a part of this rotate. So rotate from here, this original thing, the 2D, and convert per they rotate this 2D to based on the this XL, and make that into this uplift, and then the rotate based on the Z. So the reason we move this from origin to the negative X is just to ensure we are doing this rotate with a certain angle. If we don't have this translate, you will rotate just here. So it's no change and no move. Then this first is make that in the uplift, and then rotate just 70 degrees. So that is the effect for this translate first, then rotate second. And what we are going to do is let's save this, and we made the second one. We'll continue to make the second rotate, and we will don't change those rotate, but we give our M as the perimeter. We do a mirror. So mirror is go to the another side. So that is what we can do and learn last video. So first is we have this rotate until here, and we rotate extrude until here, and then we add rotate. Now it's already 3D. The shape, so you should use the 3D rotate, not the rotate in this 2D part. So what we did is we make this way. You can see we rotate based on X, and then we make our mirror, let's see if we do this on 0, 0, 0, then that's no change on mirror, so no change. But if we make that in 1, that will change to here. So this will give us our positive area. So that's the reason is we should use our for loop. So we gave m our 1 is 0, 1 is 1 as the ending, and the step is 1, and we can use here. So the purpose is we want to have both. So you have a mirror in the second step, but we need to keep that original one here. So that is the second model. The for loop m is just take 0 or 1. So let's save. So far, the newer version is still running smoothly. So, and what we will going to do on this one, let's see. So what's the difference we will have is also our translate. Before this mirror, we do our one more translate. Translate cosine arc angle times angle, and then after that we do the mirror. So let's see the arc radius unknown. So we have this. Oh, it's an archy. Now you can see here. So what we did is we make their translate and then do the mirror. And what's the R key? So we still have the here. Yeah, we should let them to join each other. So that is this translate means. So now we have this one. Let's come to here. This looks like it's this area. So we put this, and we can start all this part. So we can later on is have this for loop to make the complex pattern. But for now, we have our the basic. We can call this our base, the base shape. So let's save this. In this case, too, is helpful to sketch out the whole thing and set up our equation that establish a relationship between archy angle, archy radius, archy width. So we should have those, and then we are missing this one, archy radius. Is this archy width divided by 2 minus 2 of this arc angle. That's the archy. So we don't have this. This is the archy angle, and we have archy width. So we define this and replace this angle, because we need to use the angle to define the radius. Yeah. So that we gave are some the width, different width, the perimeter. So let's go further. So we will use this number 4. The last thing missing is 2 vertical column between below our the arc. Vertical part is this part. So we need to build this as our sample parts. So now what we have on hand. So our archy. So we're starting to call this as our archy module. And with those modules, so we have a width, we have 50, base 5, angle 75. So let's give a 75. And the pillar height, also have a pillar height as another perimeter. pillar height is 50. That is our the perimeter. Then what we will have is we will make this tab, and I put another one of these, and I call arc. Just by default, so I should get the same. So what's the difference is syntax error. So must something between this perimeter is not the semicolon, it's the colon. Next, the arrow, ignore unknown module arc. So I keep using arc because arc is my EA modeling tool, so it's I typed as too many times. So sorry for that. But now I think is we resume our model, and the first is we calculate our arc radius. So let me put that tab. And we make some basic shape. Basic shape is this one. So join this arc, and we copy this coming to the front. So it's inside the internal or sub module. So we call that is a basic shape. And put those inside. Then we have a basic shape and translate this to the pillar height. So we'll make that in the vertical is higher, and for M is 0 or 1, mirror this and translate this, and the union for this. Actually, this we should be able to call translate. So from here, we replace that. Union rotate and translate. Yep, just double times. And let's see this curly braces is coming to where? So this one is go to here, and this one is go to no. So this one. So union we are missing one. Okay. Let's say we have this base shape now. So now if we starting to change, let's say I put height is 70, is higher, and if I put angle is 45, it's just more smooth. So now we keep it 75. Let's save that. Now good is we have our unit of this base shape. Let's stop here and use next video to continue. Thank you for watching.